In the previous lecture, we understand some of the parameters of flat belt without any slip condition. Now we are going to discuss flat belt with slip condition. So the schematics are very much similar to the previous lecture. We have two shafts, shaft number 1, shaft number 2. Pulleys are mounted over the shafts, and then belt is looped around both the pulleys to transmit power from driver pulley to the driven pulley. The angle of rotation or direction of rotation of driver pulley and the driven pulley, they are same, anti-clockwise direction. Diameter D1 represents the diameter of pulley 1, N1 represents RPM of pulley 1, D2 represents diameter of pulley 2 or the driven pulley, and 2 represents the RPM of driven pulley. Same to previous lecture, we have two sides, tight side and the slack side. Tension T1 represents the tension in the belt at the tight side, and T2 represents tension in slack sides. Now with slip, V1 will not be equal to V2. So both these linear velocity of belts, like V1 represent the linear velocity of belt at tight side with respect to the driver pulley, whereas V2 represents the velocity of belt at slack side with respect to driven pulley. So now, because there is slip in both these pulleys, there will be slip when there is contact between pulley and belt. Pulley and belt. So whenever there is slip, both the linear velocities V1 and V2 will not be equal to each other. In case of slip condition, the effective velocity between the belt at tight side and the driver pulley will be somewhat different from your expectation, and similarly the velocity at the slack side and the driven pulley will also be much different from what you perceive. Here there are terms represented by percentage SP1 and percentage SP2. What they are? Basically, percentage SP1 represents percentage slip between the belt and the driver pulley, and the percentage SP2 represents percentage slip of belt and the driven pulley. So first calculate how much will be the linear velocity, or how much will be the effective linear velocity between the belt and the driver pulley. As we know, V1 is the velocity of belt relative to the driver pulley. However, due to the slip, this velocity will be reduced how much amount? By the slip percentage into velocity 1. As we know that the percentage slip or any percentage can be calculated by dividing the value by 100. So here is the explanation. So what we are doing here, velocity V1 will be subtracted from the percentage slip, which is SP1 by 100 into velocity 1. So this will be equal to velocity V1 is taking common, so the inside the bracket the terms will be left as 1 minus SP1 or slip 1 divided by 100. Similarly, now the story become a little bit difficult because we are going to find the effective linear velocity at the slack side between the belt and the driven pulley. We already know this term, which is the effective velocity between belt and the driven pulley. So due to slip, the effective velocity will not be v1, but it will be a little bit less than v1. How much less? It will be this much less. Or the final result was v1 into 1 minus sp1 by 100. So sp1 is the slip between belt and the driver pulley. So how much will be the effective velocity at the slack side? It will be equal to the velocity that comes from the driver pulley and the belt, driver pulley and the belt. Here it is from the previous slide, with just taking this term here minus sp2 or slip 2 by 100, which is a slip 2%, into the velocity that is coming from the driver pulley. I will repeat it again. The effective velocity v2 at the slick side of the belt, slick side of belt and the driven pulley will be equal to the velocity, the effective velocity at the driver pulley and the belt minus the slip percent, which is sp2 by 100, into the velocity that is coming inside. So this much amount is further deducted from the velocity that is coming from the driver pulley. If we simplify this, or taking common v1, like the inside term, both are same, so we taking common this v1 into 1 minus sp1 by 100 outside, then the inside it will be left, this become 1 minus sp2 by 100. So this is simple mathematics, nothing more. So we are taking common of 1 minus sp1 by 100, and if we multiply this the terms in the bracket, 1 to 1 1 minus sp1 by 100 into 1 is minus sp1 by 100. Similarly 1 multiplied by minus sp2 by 100, it's minus 2 by 100, and if sp1 by 100 multiplied by sp2 by 100, then minus minus sign will be multiply and become positive, and the inner term will become sp1 plus sp2 divided by 10,000. This term, because it's divided by a big number, but 10,000, is considered to be negligible or very small, so we are ignoring this term. And if we ignore this term, then the remaining terms will be 1 minus sp1 by 100 minus sp2 by 100, bracket close. Or if we further simplify it, it becomes 1 minus sp1 plus sp2 divided by 10,000. Further, for the sake of simplicity, we are taking sp1 slip 1 plus sp2 slip 2 as equivalent to sp, the common slip of the driver and the driven pulley, as a sp. So if we put the sp here, the effective velocity between the belt and the driven pulley becomes v1 into 1 minus sp divided by 10,000, bracket close. So this is the final term we are getting here, but there as you can see, the velocity v2 will never be equal to V1 because of the slip between driver pulley and the belt and slip between driven pulley and the belt. And how much amount is lost due to slip is the term inside the bracket, which is 1 minus SP divided by 10,000, whereas SP is equal to SP1 plus SP2. Another very important formula is to find the length of flat belt. For the sake of convenience, I just wrote down the formula. Here the additional term is the x, which is the distance between center of the driver pulley to the center of driven pulley. If we take distance from center to center, it is x, and the formula of length of the flat belt is equal to 2x plus pi into d1 d2 divided by 2 plus d1 minus d2 whole square divided by 4x. So if you want to calculate how much will be the length of the belt, so by knowing the distance between the center to center distance between the driver and the driven pulley and the diameters of driver and the driven pulley, you can easily find the length of a belt that is looping around the driver and the driven pulley. Similarly, we can also find the tension in the flat open belt. The formula is very simple. It's tension at the tight side by the tension in the slack side equal to e raised to power mu theta, where mu is the coefficient of friction and theta is the wrap angle. What is the wrap angle? As you can see, the pulley and the contact between pulley and the belt, it starts from here and ends at here. So we count the angle start from here and end at here. So this whole angle become wrap angle theta, because this belt is wrapping the pulley. So whatever the contact between belt and pulley is, we will count as the wrap angle. And to find a tension between the ratio of tension between the tight and slack side, it can be easily found by e raised to power mu theta. If we know the coefficient of friction and the wrap angle, then we can find the tension between tension ratio of tight side to the slack side. Further, as this belt is revolving around a pulley, so there will be acting a centrifugal force. If you recall your memory, so centrifugal force is a force which is acting outward. The opposite of centrifugal force is the centripetal force. It's acting inward. So in case of centrifugal force, there will be tension, and this tension is represented by Tc. So Tc is different from the T1 and T2. T1 is the tension at the tight side, T2 is the tension at the slack side, whereas the tension due to the centrifugal force of the belt, because if this belt is revolving around, then it will try to move outward, move outward, move outward, and due to this movement there will be acting additional tension in the belt, which is represented by Tc or centrifugal tension, and the Tc is equal to mass per unit length m into the square of linear velocity. Very simple formula. Whereas effective tension between effective tension at the tight side becomes T1, the tension at the tight side, plus the centrifugal tension. Similarly, the effective tension in the slag side becomes um, tension in the slag side, which is T2 plus the centrifugal tension. So here the effective tensions are here. In the tight side becomes T1 plus Tc, and the slag side become T2 plus Tc. A very important phenomena that we are going to discuss in this slide is how much power will be transmitted from the driver shaft to the driven shaft. As you know, the concept of this belt and pulley arrangement is to transmit power from the driver shaft to the driven shaft. So it's equally important to find this maximum power transmission equation. How we will find it? It's very simple. We already have gone through series of equation. We will utilize the equation that were discussed in the previous slides, and by manipulating different equation we can have a set of equation which can give us the maximum power transmission in flat open belt. So the first equation that we will going to use here is the power formula. So P is the power, which is equal to tension in the tight side minus tension in the slack side multiplied by the linear velocity v. So this is the general formula for power. We already know the ratio of tension at the tension at the tight side divided by tension at the slack side is equal to e raised to power mu theta, where mu is the coefficient of friction and theta is the wrap angle. Or we can just say that T2 is equal to T1 by e raised to power mu theta. So just put this T2 value here in the equation, just as it. What we will get, P is equal to T1 minus T1 divided by E mu theta, bracket close, into V. Or as you can see, if we take T1 common, then what will left inside the bracket? 1 minus 1 by e raised to power mu theta. Coefficient of fraction, it's constant. The wrap angle, it will never change, it is constant. So this whole term is constant. So we are just equating this whole term, which is a constant, as C. So that the equation become so much simplified, which is P is equal to T1 C, which is a constant, into V. As we know from the earlier slides, the effective tension is T1 plus Tc, or if we move T1 at one side, then it becomes equal to T minus Tc. And we also know that the Tc, the centrifugal tension, is equal to mass per unit length m into linear velocity square. So if we put this Tc here in this equation, then the T1 becomes equal to T minus mv square. So just put the value of T1 in this equation, the power equation. What we will get here, P is equal to Cv, this Cv, whereas inside the bracket is the value of T1. So just multiply Cv to the terms inside the bracket. What we will get, Cvt minus Cmv cube. So this equation gives us a sense that power is a function of velocity. Higher the velocity of belt, more power will be transmitted. So P is a function of V. To find the maximum power, what we can do here, by simplifying, by simply using the mathematical interpretation, that if we take the derivative of P, this equation, with respect to V, and then equate it to equal to 0, then we will get the velocity at which there is a maximum power transmission. I will repeat it again. We have this final equation, which is P is equal to CVT minus CMV cube. In order to find a maximum power, what we will do, because we know that power is a function of V, so what we will be doing here, we will take the derivative of this equation with respect to V, and then equate them equal to 0, just as this, derivative of P with respect to V and equate equal to 0. So derivative of this term is, with respect to V, is Ct. Here's a Ct, and derivative of this term is 3 comes here, Cm, and V 3 minus 1, it becomes V square. So here 3 Cm V square, equate equal to 0. What we will get, by taking C common from this equation and divide it to the 0, it becomes 0. Anything divided by 0 is 0. Sorry, anything divided to 0 is 0. So what we will get, t minus 3m v square is equal to 0, and finally just taking v at left hand side and remaining terms at the right hand side, we will have this final equation, which is v is equal to under root t minus 3m. So if we put this v here and here, then we will get the maximum power transmitted by the pulley to the belt. So I hope you understand the concepts that were delivered in this lecture. However, if you feel some difficulty, then please ask the question via WhatsApp or Google Classroom. Thanks for paying attention.